Today I'm going to show you how to use the Excel's solver function to solve a linear programming problem. So the first thing I would encourage you to do is to open Excel and set up your Excel page in a somewhat similar manner to what I have right here. Now I wouldn't worry so much about making sure the formatting is the same. That's just going to be here to make it a little bit easier for you to follow along with the way that I have this. So you're going to have basically three different areas. One for variables. This is where your final answer is going to go for x and y. You have objective function, which is like your something times x plus something times y is going to give you your value for your objective function. And then you are subject to some constraints, this is the table that you'll be creating. Your constraints for, you can have 2 or 3 or even more constraints, and then what restrictions are put on those. So just to be able to read the formatting that I've done here to make it easier for you, I have this kind of whitish box is the solver output. We're not going to do that until the very end, so that's where the actual answers are going to go. We have any of these orangish colored boxes. That's where we're actually going to type numbers in. And then these darker boxes are where we're actually going to have formulas. So we're going to type formulas into those boxes. So I'll just get right into it. This is a problem that I created. So we have over here, you're managing a pie company that makes 2 types of pie. We have apple and blueberry. Each apple pie requires 3 eggs and 2 cups of sugar. Each blueberry pie requires 5 eggs and 1 cup of sugar. You have in stock 400 eggs and 206 cups of sugar. You make a profit of $4 on each apple pie and $3 on each blueberry pie. The question asks us, how many of each type of pie should you make in order to earn the largest profit? Okay, so we know that we're trying to maximize profit. That's what it's telling us right here. What should we do in order to maximize profit? Well, if we look earlier here, they tell us that you make a profit of $4 on each apple pie and $3 on each blueberry pie. So profit is linked to how many of each of these pies we sell. So that means our x and y variables are going to have to be apple and blueberry pies. So I can fill that in right over here to make this a little bit more specific. I could say, all right, x is now going to be the number of apple pies that I make. I'll just put apple, and then y can be blueberry. And I can put that in place of all of my x and y's, and just to be quick here, I'm just going to copy these and paste them down. Okay? So like I was saying before, we're going to ignore this first part for right now, because this is going to be the very last thing we're going to do is to actually get values for how many apple and blueberry pies we're going to make. That's the whole point of this. So we're going to leave that for now, and we're going to fill in the rest of the inputs here. So now going to the objective function. Objective function is always going to be related to something that you're either maximizing or minimizing. And remember, in this case, it says how many of each type of pie should you make in order to earn the largest profit, right? So that means the objective function is going to be profit is equal to, and then it's some number of apple pies and some number of blueberry pies are going to get us the profit. But actually, if you look here, they say we make $4 on each apple pie, so we can put 4 there, and we make $3 on each blueberry pie. That's going to be 3 right there. So these are the orange cells, so I know these are our typed inputs. And then right here, I need to put a formula in, which is going to calculate the profit given that I make $4 on each apple pie and $3 on each blueberry pie. So if you were to actually do the linear programming problem, typically you'd write out this step as profit equals, well, maybe 4x plus 3y. And how would you find the profit? Well, you'd have to write a formula here. So if I'm in the cell, I can do equal sign. Well, it'd be 4 times the number of apple pies that I make, which is going to be filled in at the end right here. So I can just put that in. And it's going to be plus. And then it's kind of hiding this now. I can't really click on the blueberry cell, but it looks like it's D7. So it's going to be plus D7 times the number of blueberry pies that I make, which is going to be put up here. I can press enter. It's going to give me a value of 0 for now, but that's fine. That's going to change later when we actually run the solver. Okay, so now we can move on to our constraints. So if we read back in the problem, they tell us that each apple pie requires 3 eggs and 2 cups of sugar. So that means we're constrained by both eggs and sugar. Now you may or may not need this third constraint, or possibly even more than 3 constraints. In this case, the only constraints we have are eggs and sugar, so I'm just going to leave this last row blank. And again, we said we have 3 eggs and 2 cups of sugar are required for an apple pie, so I could put 3 and 2. And then over here, each blueberry pie requires 5 eggs and 1 cup of sugar. Okay, and I'm going to skip over this formula cell for now and go into the next sentence that says you have in stock 400 eggs, that's a restriction, 400 eggs, and 206 cups of sugar. Okay. This column heading could also potentially be requirements, but in this case it's actually a restriction. This is this is how many eggs and how many cups of sugar we have, so we can't go beyond those numbers. So we're restricted to 400. Well, how much do we actually make, or how many eggs are we actually using, I guess, and how many cups of sugar are we actually using? So this is going to be another formula since it's a formula cell. So I'll do equals. Well, the number of eggs I use is equal to, well, the number of eggs per apple pie, which is 3, and we multiply that by the number of apple pies that we make, which once again we still don't know that number, but that'll get filled in later. And then plus, you'd also have to include how many eggs we use for blueberry pies. So then we'd need this cell. That's going to be D11. It's not letting me click on it, so I'll just type in D11 times the number of blueberry pies. And we can do enter. It's going to be 0 for now. That will change later. And we could do the same thing down here for sugar. 2 cups of sugar for every apple pie, so 2 times this cell, plus, and then it's looking like a D12 times the number of blueberries. Okay, so once you have all of those cells filled in, you are ready to go to the Excel solver. Now I purposely uninstalled the solver just in case you don't have it on your computer. You should only have to really install it once, but just in case you didn't have it, I took it off my computer just to show you how you would get it. So if you already have it, it should be in the data tab all the way over here on the right. You'll see something that says data or solver around here somewhere, but I don't have it right now. So if you go to file and you scroll down to options, and you go to add-ins, you have Excel add-ins, and then you do the solver add-in, press OK, and it should pop up here in just a second. It's loading. There it goes, the solver. So we can click on solver. Okay, so it says set objective, right? So remember, this is the objective function. Our objective is this cell right here. We want this cell to be maximized. Okay, we want that cell to be maximized because we're trying to maximize the profit. That was the objective. And we want to do this by changing these cells right here. We want to change the variable cells, which are currently just blank right now. And we want to be subject to the constraints, and you have to add some constraints, and those are going to be from down here. So we can go add. First thing is we want our actual number of eggs to use. We want that to be less than or equal to 400. Okay, so we can add that. And we also want the number of cups of sugar, the actual number of cups of sugar, to be less than or equal to 206. That's okay. We do want to make the unconstrained variables non-negative because we don't want to have negatives in this problem. And then you'll want to set this to the simplex linear programming. And I think that's everything we need here. So if we do solve, there we go. So it wants to ask us, okay, do we want to keep the solver solution? Just say yes, okay. And you can see up here it has inputted answers for us here. It's saying, okay, you should make 90 apple pies, and you should make 26 blueberry pies, and that will make you a profit of $438. And it looks like you're going to use exactly the number of eggs and exactly the number of cups of sugar that you were allowed to use. So sometimes these won't be the same as the restrictions, but it looks like they were in this case. Okay, so I think that's just about everything. So thank you for watching the video, and hopefully this was helpful.